Okay, so we've got three spectroscopic graphs here, Mass Spec, carbon-13 and an IR, and we're going to see if we can identify the unknown molecule. Let's start with the Mass Spec graph. We can see here that we have a peak at 58, and there's actually a peak at 59. But initially I'm going to assume that the peak at 58 here, MZ, is the actual molar mass of the molecule, and we'll go back and reconfirm that. So the next I'm going to look at is the carbon-13 NMR. We can see that we have three unique carbon environments because we have three distinct peaks. We can see that there is one peak at 62. That's most likely from a carbon that's attached to a single bond oxygen. And we have two peaks in between 100 and 140, most likely arise from a carbon double bond carbon. If we go and look at our IR graph, we can see here that we have this distinct peak here between about 3,000 and 3,600, and this shape of this peak and where it's placed is going to be from an OH stretch from an alcohol group, not a carboxylic acid, but an alcohol group. Now see this little sharp peak here? This can originate, this could be an indication that there is a carbon double bond carbon. Now, if I put these things together, that is, I have three carbons, two of them are a double bond, and I have the other one attached to an oxygen that must be an OH group, then if I add up the molar mass of all of these atoms, it is 58. So, therefore, when we go back and look at the mass spec that was 58, I'm happy, and we're just going to assume that this next peak that is considerably smaller is just an M+1 peak, and it's accumulated from all of the isotopes of the heavier, so from the heavier isotopes. Okay, and that's this molecule sorted.